So we're going to have a look at our second lesson on pre-calculus, still focusing on speed time graphs. However, we're going to be focusing on how you can use them to calculate the distance that's been travelled. Okay, there are three things that you're going to need to make sure that you're confident in using for this lesson. So if you just want to pause for a second and write down what the answer to these three area formulae are, and then hit play when you're ready to recap and check them. Okay, so everyone should be confident with the area of a rectangle is just length times width or base times height, depending on what you're more comfortable using. The area of a triangle then is a half times the base times the perpendicular height. So remember, the perpendicular height means it needs to be at a right angle to the base. You can write that as base times height over 2, that's the same thing. And the area of a trapezium then is a half a plus b multiplied by h. Remember, a and b are the two parallel sides, and h is then the height or the gap between them. Again, that can be written as a plus b in brackets times h all over 2. Either formula is correct at that point. Right, so we're going to look at how we can now use speed time graphs to calculate the distance travelled. So I want you to pause at this point, have a go at the three questions at the bottom, and then when you're ready for me to go through them with you, hit play again. So part A says, what was the distance travelled in the first 5 seconds? And I'm guessing there are a few of you that have probably written down 50 at this point. And I'm guessing that's come from the fact that it was 5 seconds and 10 meters per second. And so you thought it would be 50. However, that's not a distance time graph. This is a speed time graph. And remember, this line here that has a positive gradient is showing me acceleration. And the acceleration means that the speed then is increasing and getting faster and faster over that period of time. So it's not a constant speed. And actually, we need to do this in a different way. So the first thing and the most important thing that you need to learn for this lesson is how you actually calculate the distance travelled from a speed time graph. So the area underneath the graph is actually equivalent to the distance travelled. So if we now look again at question A, what was the distance travelled in the first 5 seconds? You'll see that I'm showing that there with the red line. And within that red line, I can see that I've got a triangle with a base of 5 and a perpendicular height of 10. And so to calculate the distance travelled, I just need to work out the area of that triangle. So remember, that was base times height divided by 2. So 10 times 5 gives me 50, divided by 2 tells me in the first 5 seconds we would have travelled 25 metres. If we then look at part B, so what was the distance travelled between 5 and 15 seconds? Again, that's my highlighted section there. This time I've got a rectangle with a height of 10 and a width of 10. Just be careful that the width is still from 5 to 15, so that's where it's coming from. And therefore a rectangle was just base times height, so 10 times 10 giving me 100 metres travelled. Part C then wants me to work out what's the average speed of the whole journey. So to be able to work out the average speed, I need to work out what the total distance travelled was. And to do that, I need the third part of the graph. So I'm going to look at the last part, which again is a triangle with a base of 20, because it's going from 15 to 35 in seconds, and a height of 10. Therefore, the distance I will have travelled at that point would be 10 times 20 and then half it to give me 100 metres. So my next thing I need to work out then is the total distance travelled on the graph. So it's going to be the 25 metres in the first triangle we worked out, plus the 100 metres in the rectangle, plus the 100 metres in this particular triangle at the end. So far, that's a total of 225 metres travelled on the whole journey. And then to work out the speed, obviously you need to make sure that you know your speed, distance, time formula, and speed can be calculated then by us doing the next step, okay, which is then our distance, which was 225 metres, divided by the total amount of time travelled, which again we went from 0 to 35 seconds, and that gives us 6.43 metres per second when rounded to 2 decimal places. Okay, so hopefully you're all right with that one. And this is how it works when it's a nice straightforward graph where everything involves straight lines. Okay, so now I want to show you how you can do one when it's got a curved line. So remember, this is where we haven't got constant acceleration, it's changing over time. So on this particular question, we're asked to estimate the average speed of the whole journey. So I just want you to think for a second, why is this one going to be an estimate? Okay, it's going to be an estimate because it's going to be very difficult for us to be able to calculate the exact area underneath a curved line. So I'm going to show you how you can do this. We're going to start off with the most straightforward part, which is the triangle on the right hand side. So hopefully you're able to calculate the area of that bit. So again, hit pause for a second and work out what your area is at this point. Okay, so it has a width on the bottom of the base of 6 and a height of 12, and therefore base times height divided by 2 tells me in that part of the graph we will have travelled 36 metres. Again, the next part of the graph is still quite straightforward because it's going to be a rectangle, so can you work out the area for that part for me? So for this bit, 12 times 4 tells me it's 48 metres. When it comes to the curve bit, we have to split it up into smaller shapes so that they're much easier for us to deal with, and therefore we can see where the estimating part comes from. So I'm going to show you how to do this. We can split it into different shapes, and as you can see, most of them are trapeziums, and it's got a little triangle at the end. So I'm just going to go through this first one with you. So between 10 and 14, the area of a trapezium, remember, was a half times the two parallel sides added together multiplied by the height. So remember, your trapezium's been turned around or rotated at this point, and the two parallel sides is this part and this part here. So it's going to be a half times the two parallel sides added together multiplied by the height, which is going to be the gap between the 10 and the 4. And if you just double check each of these little squares, because the 5 little squares is worth 2, each little square is then worth 0.4. So at this point here, I'm at 10.04, and obviously at this point here, I'm at 12. So I'm going to add the two of them together, half it, and multiply it by the width or the height at that point, which was 4, and that gives me 44.8 meters. Again, I'd like you to pause at this point and then see if you can work out the areas of the remaining 3 sections, and then when you're ready for me to go through that with you, hit play again. Okay, so the next section down then should have been a half of 8 plus 10.4, and then again multiplied by 4, giving us 36.8 meters. The next one down is a half of 3.6 plus 8 for the two parallel sides, again multiplied by 4, giving us 23.2 meters, and the triangle at the end is 2 times 3.6 divided by 2, giving us 3.6 meters. So we then just need to work out what our total distance travelled is. So we're going to do that by adding up all of the parts. So the 3.6, add the 23.2, added to the 36.8, added to the 44.8, added to 44, added to 36, and we end up again with 192.4 meters as our total distance travelled. We then need to use that to estimate the average speed of the whole journey. So remember, the average speed is going to involve the distance travelled and the time that we spent travelling. So therefore, our estimated average speed is going to be 192.4 divided by the 24 seconds, which to one decimal place is 8.0 meters per second. Okay, another type of question that they like to add on the end is to ask you whether it was an overestimate or an underestimate. Okay, and if you have a look at the graph, if you can see the red line, that's just slightly underneath the black line, so the original graph. So the parts that we've estimated are slightly lower than each of the actual parts of the graph, so therefore this would be an underestimate. If we were drawing lines slightly above, then it would be an overestimate. Sometimes you can get some that where it's above on parts and below on others, so it kind of averages out. Okay, so have a go at the practice questions on these and let me know if you need any help.